Hello and good evening. Welcome to SpaceTech Europe online hackathon. So happy to welcome you all. We have our participants ready and waiting in Zoom, and hopefully you're watching wherever you're watching live. You are ready to support the teams. We have 8 teams pitching tonight, so a big applause for all of them for making the 48 hours and creating amazing results. Of course, before we get to the live pitches, we need to thank a lot of people for making this weekend happen, and our sponsors, our organizers, our supporters. I need to do a very special thank you to the embassy, the US Embassy in Kiev, and the America House and SpaceTech for taking this amazing topic, tackling together with us and making this 48 hours possible. We started actually SpaceTech Europe in 2016. Makes me feel so old because I was then organizing the very first hackathon. I'm super happy to see how much it has evolved. We're now doing online hacks across Europe. We have so many countries, 15 actually to be precise, participants from. So the SpaceTech domain is really growing, it's really pumping, and the community is growing strong. So I'm super happy that we're having this event. But I also have a co-host here. Siim is also here with me, and I'm going to give over the words to you to give some more thank yous.
Yeah, it's a pleasure. Thank you, Kai. And we've been organizing this event for many months now. And with every hackathon, it can't be brought to life with good partners. And I'm super happy that we have so many different partners all across Europe, from the Balkans to Portugal, Spain, UK, to the Baltics, from everywhere. So space hubs across Europe supporting us and making sure that this event is a success. So thanks to all of you.
Oh, so we started on Friday. It feels like ages ago already. 8 teams and 15 countries, I already said. You can see from the few pictures as well that this, our Zoom windows didn't even fit all of the people that we had. And our team was working together here from the Tallinn office to the world. So just really, now I'm like talking to our teams that are waiting in Zoom, like you all did amazing. We're just the stories that you tell us. We have one team that's 2 people from both sides of the world working together. One is sleeping and the other is working, and then they switch around. We have our favorite hackathon story, when you wake up and you join a hackathon and in 30 minutes you have an idea and a team together, and now you're pitching live 48 hours. So that's the real startup spirit. So really diverse group of people together here with amazing expertise in the space domain. So I really want to applaud all of our teams. I know that you are there. Hopefully we can see you as well already ready in Zoom. So saying hi from 15 countries. I hope that, yes, hello everybody who has their videos and cameras on. Hi. I'm seeing that you're ready and some smiling great eyes. Super good, and a big thank you to you as well, of course, that you have joined us for this crazy hacking weekend. All right, we have some more things to share.
Yeah, you want to start pitching, but still, we're rambling on. So if you're joining us, make sure to take some pictures. Tell us where you're from, where you're tuning in from. As we mentioned, we have many countries, and we're not only in Europe, we're also in the States with a couple of participants. Take some pictures, tag us, we'll share them, and use the hashtag SpaceTech Europe.
Yep, and we're here to evaluate the teams and the pitches. Of course, we don't have to do the job. We're really happy. We have the jury members doing that. And we talked about this already on Friday with the teams, but we also usually have those 4 pillars for the jury to kind of help them make the decision. And it's been really interesting actually to see kind of different cultures of hackathons and, kind of people coming from the States and being like really kind of coding heavy hackers. And then we might be a little bit more on the kind of validation and business case side. I think that the hackathon needs to be kind of like this very sweet spot in the middle, right? So the 4 pillars that the jury is going to evaluate on is the prototype, of course, the thing that you built here, this is really important, but also the business potential and the impact that it might have then, and especially in the space domain, it's not going to happen on Monday, but it might happen on a longer term scale. We really want to see that this would change the industry, would give some kind of a new solution and have real impact. Of course, the team, as I mentioned, we have some crazy guys here, really smart people in the space domain. So if you have that kind of potential and competence and skill in your team, that's a winning point as well. And of course, those 3 minutes, so no pressure, but you need to fit those 48 hours of effort that your team did into those 3 minutes. So pitchers, I hope that you are ready for that. And as said, we have the jury, they're making that decision. So Sim, who do we have in the jury?
Well, it's all fun and games, but at the end of the day, we still need to decide on the winners as well. So in the jury, we have Michael and Abedin from the US Embassy in Kiev, one of the main organizers. So hi Michael, hi Abedin. From the Yuzhnoye State Design Office, we have Maxim and Dimitro. And then from 2 ESAPICs around Europe, from ESAPIC Estonia, we have the project manager and head of operations there, Sven Lilla. And from Cyprus, we also have Panayotis, sorry. So it's definitely not going to be an easy evening for them, but I think an interesting one nonetheless.
And of course, we're giving out prizes, so can't do a competition without giving something great. And as I said on Friday, of course, they're coming from organizations and partners that can help you after the hackathon. It's really important to us that the prizes really push the teams forward, give them some new connections, and that can really help them to take the next step. So prizes from companies and organizations like Startup Day, like Space Hubs Network, like Slovak Space Office, of course, ESA Business Incubation Center, Innovation Kitchen, Yuzhnoye Design Office, and Gravity Incubator Program. So many different things that can help the projects along. So thank you for these as well, our supporters that giving out prizes. So time for show. Sim doesn't want to play with me at all. All right. So what's going to happen now?
So now, all of you, we have practiced, and I hope we have practiced amongst yourselves as well. 3 minutes for your pitch, and then after that, from the jury, they will ask you questions. 2 minutes for that, and I think let's kick it off. As Kai, you mentioned, one of the favorites of the favorite stories of the hackathon so far. Max writing to me saying that okay, I just woke up, I want to submit that idea, and half an hour later writing to me that I have a team together. Let's hack away. So Max, are you with us?
Yeah, I'm here.
Okay. So if you're ready, we're ready.
All right. Okay, so hi, I'm Max Perello, and I'm actually from the US. I know it's kind of weird that I'm here, but actually the story of how I ended up in Kyiv is probably best saved for later. So basically, by the end of the year this year, there will have been about 130 rocket launches worldwide. This translates to somewhere well into the billions of dollars. Millions of that are paid to effective travel agents who organize groups of satellites to fly on a given rocket. However, there's no easy way for potential customers to compare all launch providers and brokers. In some cases, there are sites that index a subset of them, and in other cases, in-person gatherings, where those who own satellites can shop around. Last I checked, we were in the 21st century. Why anyone launching a satellite, a pretty advanced piece of technology, should be forced to go to individual providers for quotes, or worse yet, an in-person gathering, is completely beyond me. That's why we will compile any available options into an easily accessible website with a simple interface. You can think of it as booking.com for space flights. During the hackathon, I had the opportunity to speak to some real-world launch providers, namely one at Isospace, who seemed to think that at a minimum, there's definitely room for improvement in the field. Those are his words, not mine. Now, as I mentioned, there are some other players in the space, but they seem to both charge excessively high fees and also require that you effectively let them fully handle the launch setup. However, we believe that there's room for a service that takes minimal fees and simply refers the customer directly to the broker or launch provider of their choice. This also means that operating costs for our service will be absolutely minimal, simply redirecting potential customers and collecting a comparatively small referral fee in the process. As for our current team, it is small. I'm the idea guy and also a software engineer, and Merka is the designer. That may sound tiny, but actually that's a positive because it translates to extreme flexibility, meaning we can take on whoever we decide is best for the job at the roles we actually need without any additional baggage. In short, what I've just pitched to you is a business with very low operating costs that stands poised to take a small chunk of this continually accelerating market. I don't know about you, but even just a small chunk of a multi-billion-dollar market sounds pretty appetizing to me. What's more, there's even more business to be had once the satellites get up into space, through things like renting out onboard instruments and more. Anyway, regardless of the outcome, thanks for listening to my pitch. I appreciate you and the mentors taking the time to help out this weekend. If nothing else, it presents an opportunity to work with cool people and explore new ideas, learning all the while. Thank you. That's it.
Thank you. Very
Thank you,
nice.
Max. If you're ever in Tallinn, shoot me a line and we'll get in touch, and I'll happily listen to the story of how you ended in Kiev from the States. But any questions from the jury?
I'm Merka. I'm supposed to share the screen, but it's disabled. So that's so sad that we couldn't share our.
So, hopefully we can sort of retroactively show it.
Yeah,
the
I think
assumption
you can.
was, I think we
Please do
can
show it. Yeah.
give a little leniency to the first group pitching.
Can you share it now? Of course, we would like to see it.
The initial
Merka,
intention
Merka,
was
can you
that
share
she
it
would
now?
be.
Should be the settings should be changed now. Or
Her
Max, can you
computer,
share it?
it's possible her computer crashed. I can.
Okay, but
can-
maybe you can do
I
it
can
then.
share it. Yep. Sure. Okay. Okay.
Super.
But I think you can run through it. But in the meantime, if the jury has any questions, please ask away. Okay.
All right. Can you share a few, Max, just some description of what's happening on the screen right
Of
now?
the demo? Sure. So actually, I'll just go back to the beginning. This should be a pretty familiar interface to people who have booked flights and stuff like that before. You choose your continent and then your launch window and your payload weight, and then you simply search. And we can see that there are a number of options here for flights. So I think I'm going to go with SpaceX, and then I can be redirected directly to their site where I can complete the booking process. And yeah,
All
that's
right.
all handled in the background.
Okay, super. I think Mike has a question.
Yeah, hey Max, very cool, great idea, I love it. I just have one quick question. Like I said, fantastic idea, but can you talk about what are some potential barriers to entry for competitors? What's gonna keep others from immediately jumping into this space?
Off the top of my head, I think we intend to develop relationships with each of the launch providers, and as I said, I've started to do that. I mean, I only mentioned basically the results of having spoken to one launch provider, but I've reached out to a ton of them, and that'll be a process of building relationships. And there's nothing that absolutely prevents new competitors from doing something similar. In the same way that there are other options to Booking.com, but by being first to market, we can become the Google, like the known brand of this space, and also have those develop those relationships. And yeah, I don't know. I don't know if that sort of answers your question.
Okay. Thanks, Max. And another question coming in from Sven.
Yeah, hi Max. Thanks for really nice pitch. My question is that what's your revenue model? I think you didn't mention it. How you will plan to make money with your idea?
So effectively, I briefly mentioned it. But basically, I mean, this is the same way that sites like Booking.com and Google Flights and stuff like that work. So when someone does a search and comes up with a list of results, that the referral or the referrer is cached in the landing site. So in this case, SpaceX would, I mean, it's not worth going into the technology of it, but effectively they will know that we sent a customer there. So even if someone doesn't book in that session, given the use of cookies and stuff like that, we can identify a unique user and say, even if someone's coming back directly to the SpaceX site, we can say, hey, they were initially referred here by Zjozdi, and then collect a small referral fee from the launch provider or broker, in this case, SpaceX.
All right. Thank you very much for the pitch. Virtual and a real applause for you from the studio. Max was our best applauder when we were pitching on Friday, so all the applause is back to you as well. Thank you so much for the presentation. All right, we're going to move on. I think, we already said it, but really good job, Max. You're the hackathon hero, going from 0 to 100 in such a short time, and really finding like a real like a real life and real business case there, and a challenge that to really solve. And when we're moving on, our next team has found the same thing, right? And I think the next team really shows how wide the space domain is and what you can do with the data coming down from space, and really apply it for challenge on Earth. So our next team, Orbital Hackers, will be presented by Mikhail. Are you here? Wave if you are.
Yes, I am. Hello. Good evening.
Good evening, Mikhail. Thank you for coming. Thank you for pitching and presenting. We'll give the microphone over to you. You can share your screen, and the 3 minutes is on the clock.
Okay, good evening to everyone. Orbital Hackers in touch. Today we want to present a prototype of our product that will give the ordinary user another source of information that will help him decide on the choice of an apartment. The person using our prototype is primarily a person who decide to buy an apartment but has doubt about the offered prices, as well as those who decide in which region of the city he is going to live. The uniqueness and novelty of our solution should lie in the use of a combination of terrestrial and space data. In our project, we use the urban atlas and maps of land cover classification that we built in our Ukraine institute, in the Space Research Institute, using satellite data of optical and radar nature. And so now a small presentation of our product will take a place. Georgi, you way out.
Yes, can everyone see the presentation?
Yes.
So here's how it looks. It's a website which provides a map where you can see in Kiev which apartments you can buy. For example, I'm interested in this one. We can see where it's located, its price, and the price that was calculated in our model. As we can see, it's way lower than compared to what it can be, so it's actually a great deal. You can buy it without any regrets that you might be scammed or anything like that. On contrary, for example, this one has a huge price margin with its current price and what you have calculated. So this means that it might be a scam since our model calculates a lot of possibilities. I mean, a lot of parameters which can influence the price, such as if there are nearby schools or if there are any nearby mall, shops, or whatever can tenants be interested in. And even such parameters as if whenever there is graveyard right outside your house, which is not very pleasant for tenants to constantly walk past graveyards. Not very positive for life, since you always see where you will end up. Yeah, so that's basically it.
Thank you, guys. Your time is up as well. So thanks for the presentation to George and Mihail. Do we have any questions from the jury? Not at the moment. Do we see any virtual hands from the jury? Yes, Michael has one.
Yeah, thank you so much. That's another super interesting idea. I have a question. So in order to determine the real price, did you develop some sort of proprietary algorithm that's creating that number?
Mihail or George?
Yes, there was developed an algorithm. As I said, there was a lot of parameters which were used in this model. And based on this algorithm, the price was calculated.
Okay, thank you. And Panayotis, you also have a question.
Yeah, I just wanted to ask, how do you make money? How are you going to make money out of this? What are you going to be charging?
I think that it's the first time our product will be able to live on donations from grateful users who saved money thanks to our application. It's our business model.
Okay, thank you, Mihail. And Abedin, you also have a question.
Sorry, I think Mike already asked a similar question that I had, because to me, like, question was, how did you build the price for the apartment? And also, the other question I would have, would it be any kind of like further link from that icon when I click on it that would give me the square footage of the or square meters of the place or price per square meter or something like that? Or is just basic comparison of two prices?
Of course, all of this can be added in the future. Different little features that can describe the flat or real estate that you want to buy.
Thank you for the questions. Thank you for the answers. An applause to the team for working hard for 48 hours and presenting now. All right, let's move on.
So next up, we also have a team that had quite a lot done in the past, more on the hardware side, and coming to the hackathon to take it to the next level and maybe improve their software version. So we have Igor and team Paganel LPS. Hey, Igor.
Yeah, hi. We are Paganel LPS. We have another two members here. My brother, who's a sales guy on our team. I'm business developer guy heading this particular project, and our software engineer. So we are Paganel LPS. What are we? Well, we are building an outdoor local positioning system based on something, on the technology that is pre-existing, that we already built. Now, what is the issue we are fixing? Now, all GPS, global positioning systems, they have two major problems. First, they can be jammed, and second, they can be spoofed. Now, meaning you think you are somewhere, but in reality, you can be a few meters or even a few hundred meters from the real place, you know, that you think you are. So our solution does not depend on GPS satellites. We are using pre-existing commercial K-band, usually mostly high orbit satellites. And currently we are building and testing the beacons to, to build a outdoor local positioning system using pseudo satellite approach. So those beacons as addition to it. Now, having built the prototype as the basis of this technology, we built it for the military usage. We've had our artillery, mechanized artillery guys approached us and asked our R&D team to help them with building a compass that is better than the existing solutions and cheaper, of course. Then we have done that. They're very happy right now. They are on proving grounds, finalizing final tests, and we have patented this technology. So we've done I can show you pictures if I have the time at the end. So, but during this hackathon already, we have mentors changed our perspective and depth of understanding. So thank you for that. Now, possible users besides military, the whole countries, so yeah, definitely boosting the defense capabilities of the country, having their own local positioning system is great, but a huge potential is for civil usage. All right, so like maritime navigation at seas, ships have already have complex navigating solutions, but there are never too many of those, okay? Because the story of Evergreen and others, the oil spills, things like that. It's all because of the problems with navigation. Now, we are tackling this. Now, other possible uses, farming, geology, etc. Now, there are many researchers, competitors that try to build this. Our solution is very precise because it's built on already pre-existing technology that is very super precise. Now, it uses very simple components. It means the production is highly scalable. Now, the preciseness of such systems and proneness to interference, are its Achilles heel. Now, we've got it covered because I already said we built it. Now, what impact at the end can we achieve with Paganel LPS? It's not only for Earth, guys. For the
Igor,
future exploration of planets. That's it.
Igor,
thank you very much.
Thank you for your pitch. So, if the jury has any questions, you're welcome to ask them.
I would be happy to answer.
What a great pitch as well, Igor. I'm super happy that you mentioned the mentors. Like, they do deserve all the appreciation because they've been working with all the teams, and yeah, thanks for thanking them.
We have received so much help from them. We've got some ideas that I think are great, and they're gonna change our approach, how we build it.
That's always good to hear. But a question coming in also from Panayotis.
Yeah, I wanted to ask, what have you achieved the last 48 hours? I didn't understand very well. You had the hardware, I thought I understand, and you worked more on the software. What actually you did within the last 48 hours?
Well, we have basically, designed in the last 48 hours, we've designed a prototype of a simple navigation application. We built a UX for that. It's not a beautiful UI, of course, designed, but UX is just shows how the navigation works. I can share the screen if you would like, but that's basically. And plus, we've talked, as I mentioned, we've talked with mentors, and that has been our greatest achievement, because we've talked about some new approaches to how get the data, not only from satellites, but from a lot of different other places. For example, like radio beacons that ships are using already. And, even like 3G, 4G, 5G towers. So many ideas like low Earth satellites as well, the Starlink. That is some possibilities we are going to be looking into to expand our technology.
Okay, and the last quick question from the viewers now team as well, and then Maxim, Dmitry.
Dmitry, how dimension of area which I can use the local position system?
How can you use that?
Dimension. What's dimension the area?
What do you mean area?
Area.
What is the size of the area you're supposed to?
Got it. Well, it only depends on the. If we're talking about the local positioning system itself, it only depends on how many beacons are you able to set up, or how many pre-existing transmitters, radio transmitters you are able to use. So we are able to incorporate this whole idea of using other radio transmitters that are pre-existing ones already. So the area is the whole country. If you're talking countrywide, usage of this local positioning system. And again, let me emphasize, it does not depend on GPS satellites that can be spoofed, jammed, etc.
Okay, thank you, Igor. But we'll have to move on now. But it was great to see your progress. It's awesome to hear how much the mentors have helped you, and really excited to see what the future will bring for you as well.
Thank you. Other planets as well. There are no satellites, but the local positioning system would be the key. Thank you.
Super.
Thanks a lot. We are moving on, and the next team will be Mineralis, and we have Selin ready for the presentation. Yes, I can see you already. All right, yes. The microphone
would we have the video running?
The video will be running as well, and the 3 minutes are on the clock, so go ahead.
Hello, we are Team Mineralis, celestial prospectors, and we want to help businesses to reach natural resources on Mars and asteroids. That's why me, Rino, Alan, Tai, and Bright came to this hackathon to put together a strong team for our idea. Imagine a map that shows you where gold is in your city, but on a larger scale on asteroids and Mars. We provide information regarding where particular natural resources are and how they lie in the ground. We screen out information in existing data sets about mineral resources on Mars and asteroids to construct the images from this data. We analyze that information and package it into a comprehensive catalog for businesses. As the analysis of existing data continues, we aim to then send our own orbiter with all necessary parts and sensors, such as the hyperspectral imager, context camera, attitude sensor, array of LiDAR, array of SAR radar, and surface imager to space using CubeSat format to gather our own data and add to our catalog of existing data for analysis and imaging. Once we have this catalog of information, we provide it to companies interested in space mining or generally interested in the resources on Mars. With our high accuracy geodata collected with the orbiter, we aim to ease the mining struggle of Earth for space and be able to benefit from what the solar system has to offer to us. Our project has seen quite the support and will continue after the hackathon. We hope to engage with more sponsors and introduce our idea further into the industry. In the further parts of the project, we will be working on adding these images together to make one big map of the natural resources existing in space. Well, in the future, we do hope to map all the solar system for companies who would like to mine minerals from space, but we would also like to be a safe platform provider for data acquisition, value proposition analysis, and clean, responsible, ethical trade of space resources and energy. Our solution is meant to help mining companies to save on prospecting and exploration costs, as well as on time, while hoping this platform provides a safe place where space resources can be fairly traded. We set to provide a clean, non-conflict example for the future of space mining and exchange. Thank you for listening, and if you have any questions, I will be more than happy to answer them.
Thank you, Team Mineralis. We are opening the round for jury questions, if we have someone. And again, just a big applause to you. We are praising all the teams, of course, and it was great to see that, you know, Bright and Allan starting the idea and pitching it on Friday and really getting a team together from the hackathon. We have a question from Sven.
Yeah, well, first, thanks for your pitch. Quick question. There was supposed to be a video. We didn't see it. I didn't see it. At least I didn't catch any glimpse of the demo. So what did you achieve?
We had sent it to the Garage 48 team. They would have...
The video was showing definitely on live stream, but if you didn't catch it on Zoom, then sorry, yeah, we can definitely send you the link and we will show it to the jury. So sorry about that, a bit technical errors, but we will show it then.
Question is that about your revenue model. How do you plan to earn money?
Well, we do start off with just simple databases, and first few times would not need that much funding. But once we actually have the database and once we have the catalogs is when we will try to introduce them to our sponsors. So for the first a couple months of the project, we kind of don't need funding, but after that, we will use the catalog that we've created to gather funding.
All right, any more questions? Sven? Sorry, I cut you off.
I said just thank you.
Good. All right, any other questions from the jury? We will, get you to watch the video. It was actually really, really great. So I'm a little bit sad that you didn't see it together with the pitch, but we can definitely,
Yeah, don't worry, team. The jury will definitely see it, and then this will not affect sort of the final outcome at all.
Right, any other questions the jury would like to ask? No virtual hands. All right, so let's move on. Thank you very much.
Yes, thank you. And next up, as we mentioned, we have the fifth team already, which is, I think, the most international here. We have one guy in United States, one guy in Ukraine, a time difference of 8 hours. I'm not sure if 50% of the team is here yet, but Anton, I see you here. If we're ready, we're ready.
Ready? I can share my screen?
Yeah.
Okay, let's start. Okay, hello. I would like to represent our project Orbit Bits about solutions for bits and pieces in orbit. Our team consists from me, Marmant from USA, and me from Ukraine. As you can see, we have a big growing team. So about space debris, it's a big problem. It's obstacles for the future space missions. And we want to do with this somehow. There are more than 200 of metric tons, and the number are only growing. Current solution, mostly the orbit space debris is costly. We think the more economical advantage is to collect it in the space and recycle it there. We can use a high voltage AC current to somehow glue it together there. What is our advantage? The main advantage will be, I think, artificial intelligence, which can map all the debris there and create some routes and shadows how to create this trash, garbage trash islands somewhere on the orbit. Later, we can recycle it. We mean that we not only melt it, but we can use it like radiational shield for future space missions, for example, Mars missions. We can use it as a fuel for other missions, and ours mission too. and we can use it like a kinetic tool to clean orbit. Yesterday we have some laboratory hacks. I will show you some video from it. So what we have here, we have an aluminum foil that represent our space debris. It's by this thread, it's connected to the ceiling, and I have this resonance circuit. I manually change the resonance frequency and power. It's needed to, the force of traction must be stable. If I don't lower the power when the object is clear, I have this electric discharge which will lower our efficiency. So what we find yesterday is that we can glue or stick objects together even if we're not attracted to our system. The force which created between objects is enough for them, if they are close enough, to stick. And sometimes we even have these discharges, and even the objects can melt and weld. Once I even weld the aluminum foil, which is not connected to anything. So what is our business model? So the main, we have a short range goal is to create some tool of electric field attraction tool that we can use with existing application. And long range tool is to create some sustainable system of jet boats, swarm of them, then that can work for the future, maybe regulation laws of the clean orbit, which will be in future, I think. So thank you for the attention.
Thank you, Anton. Thank you for sharing, and it's awesome to actually see some sparks and some lightning as well in your video. So I'm not sure if Armand is with us, but I hope he is joining us soon enough. Jury, any questions to Anton? Yes. Question from Sven.
Hi, thank you for the pitch. How much funds would you need to actually complete this thing, since you're solving the future problem and there won't be much funding now as a external revenue? And what would be the funding sources that you would like to get to actually complete your project?
Okay, thank you for the question. As I said, we have two goals. The short one is to create this tool of electro attraction system. It's already we make some prototyping, and the fundings, I don't think that it will be a lot of money, but it's not big prices. But for the long range goal for creating these artificial swarms of the swarms with artificial intelligence, that they work completely by themselves somewhere on orbit, that will refuel themselves from this trash and clean all this orbit. I think it's not even 10 of years, it may be 20 years, and this will be big money.
Okay, once again, thank you, Anton, for the answer. And another question coming in from Mike.
No, I actually had the same question as Sven did about the funding source. Thank you.
Okay, all covered then. If there aren't any more questions, then I think we can move on to the sixth team.
All right, another one of our star hackathon teams, big team called Flexigun. You've changed your name a few times, but Argavan, you are here already. I can see you, and yeah. Again, need to praise that you put together a very big team and managed it all. I know it's always tough to kind of, the more people you have, the more managing you need to do, and you've really done a great job. So I'm very excited to hear your pitch. So Argavan, the floor is yours.
Thank you so much. Hello, we are Flexigun, and we are going to take you with us to the wildest known unknown. Our journey began with asking one question: how to survive in unknown, and what would be the first generation of space settlements? How do they look like? So during this hackathon, we get together and we worked on this partly underground hosting compartment that is designed for supporting self-sustaining lifestyle in harsh environments and outer space, including Moon and Mars. It is a 3D printed building with materials that are excavated on site. So we are going to create reliable shelters. First, we looked into parametric design for the structure and for the shell. And we used some software such as Dynamo for studying different geometries. And we concluded that we go for the torus shape because of many different advantages that it has. As for the 3D printing, we are going to use additive construction methods that you have different videos that you can see later in the website. And the QR code is later in my photo. So we are going to do this with 3D printing from the materials that is already there. And we've worked through different solutions for example, whether we need liquid or not. We are going to have this torus shape in 2 different levels. So you can see that 4 people at a time can live there in 2 different levels. And we have 2 duplexes. We have the dust removal section. 1/4 of the design is dedicated to utilities, storage equipment, oxygen, water, etc. And we're going to have these vertical farms to sustain the food and the lifestyle, and also these social spaces for people to keep their psychology and to keep their spirit high when they are in outer space and in, for example, dark places, etc. We created a business model and a roadmap. And in the next 2 to 3 months, firstly, we're going to attract some new talent for us to help with material, with agriculture, with 3D printing, and with design. Then in the 3 to 6 months, we're going to have our first smaller scale backyard prototype to make sure that what we're suggesting is actually deliverable. After that, we would like to after 6 months, we would like to first create our first prototype in Sahara because of the sandstorms and because of the solar. We want to test whether or not it works. And then our first real prototype is going to be implemented in Antarctica. Why? Because the temperature and climate resembles Mars and Moon. And there are a lot of different actors to which they don't have hosting solutions. They're researching roads and etc. Our intermediary goal is to go to Moon. Of course, we research a little bit about different types of radiation, etc. And we're going to adjust our solution based on that. And you can later read the questions that we've answered already in our website. Our 10 years goal is, however, to go to the big red planet, Mars. That's our final frontier. And we're going to build on the lessons learned, and we're going to adjust the solution for a Martian settlement. We have been talking with different people. So some universities for scientific partnership and research support and technical assistance. We talked also through one of our contacts with different other companies that were enjoying our at least idea at this moment. And we are a big team. So thank you to everyone. We've been working extremely hard in the last 48 hours, and we gathered together during this hackathon from 8 different countries and multiple backgrounds. We have also some legal information on our website, plus patenting and some business canvas model. So thank you so much for listening to us, and we look forward for your questions.
Great, Argavan, thank you. You fit so much information in that pitch. Thanks so much. So opening the floor for jury questions, and yes, great job. It looks really, really great. And that's what I was saying before. We have some people with great expertise and backgrounds, and glad that you formed the team together. A question from Mike, please.
Great presentation. Thank you so much. And obviously a very cool idea. I love the optimism in terms of the timeline. I'm just curious, have you been able to develop any kind of even a preliminary market analysis of who is going to be potential users and purchasers of your shelters?
Yes, one of the reasons that we decided to start with Antarctica was that already, maybe Laura can help later, already there are some other countries that are researching there, and they are developing they're researching the underground, they're researching the roads, etc. But there has never been a prototype for housing there, and also the solutions that exist, they never use the underground potential, because we want to go underground to protect ourselves from different radiations, and also to keep us a little bit from the cold. So those are the first people that came to our mind. But also we were thinking that if the solution is successful, it can, due to climate change, we have a lot of problems. So potentially we can use the same prototype, especially because it's going to use local resources. in different parts of the planet.
All right, thank you. Do we have anyone else who would like to ask a question? Sven, yes.
Yeah, me, always me. Have you done competitive analysis since I know at least one project that's already, there is a fully functional Mars house that's built by French and the guys from the University of Tartu in Estonia. So what about the competition, and how do you plan to penetrate the market, or the whole market strategy?
I let I let Lauren and Natalia answer this question. I just say one phrase, that as far as they updated me, there has never been a solution that uses the underground, and we are aware that there is competition. That is not a secret. But we're going to have a different approach. But I leave the floor to my colleagues.
Yeah, okay. So thank you for the question, first of all. And secondly, from what I found, even though there are colonies to be built on Mars or to be brought there, the main things that I found are settlements which are not at least half underground. So the radiation problem wouldn't be solved up to the extent that we want to solve it. So the value proposition there would be the novel architecture first. And then of course we also have a social value proposition, which is to actually have something like this, which is new and which is sustainable to go there. So Natalia, I don't know if you want to add something, but this is pretty much the answer from my side.
All right, thank you very much. Thanks for your answer, and thank you for the presentation. That was great. All right, we're going to move on to the next team.
Yeah, and next up we have a team that's, I think, the furthest apart in Europe. 2 people in Estonia, one person in Portugal. So the distances are far apart, but I think the team worked together awesomely well. So next up, Exio, and pitching is Alexander. Hey.
Hey. So at last, energy generation in difficult environments has never been easier. We're Dandelion, and we're on a mission to create convenient, light, and modular robots that generate energy on the go. Just imagine, you're on Mars and a heavy dust storm comes on. Solar and wind energy is of no use. The airspeed goes through the roof, and conventional structures are being destroyed. While some see a challenge, we see an opportunity. What if you utilize nature instead of covering beneath it? With Dandelion, you can use the kinetic energy from movement to generate power. By using piezoelectric properties that convert deformation to energy, our robots can transform kinetic energy from slightest change to its structure. Any movement from the wind and from itself will be transformed into energetical output. Now, let's see some of our prototypes that we've done. Great. We've built over this hackathon a prototype of what it could look like. So the prototype will crash on Mars, and then it will self-assemble. It will start moving itself and generating power at the same time. It will be possible to cover itself up in the snow, and the structure itself will operate as a generator and a battery. We have also created a 3D rendition of what it could be in the end, and have tested our product on how it works in real life and if it's actually functional. And we have found out that yes, it is functional. So are you beginning to see how this light, compact, and environment efficient solution can bring in money? Our competitive advantage is compactness, lightness, and resistance to damage, crucial elements in space logistics. We can contract this technology to governments like the Luxembourg Space Agency to power research and mining, as well as sell it to commercial sector companies like Offworld and iSpace. It is simply said, more affordable and efficient way to use our product for power generation solutions. And get this, according to our calculations, it is 2 to 4 times cheaper to generate energy on Mars with our solution than with nuclear energy. This technology can even be used on Earth to generate power in harsh environments. Our plan is to roll out a completely working prototype by April 2022. We're Dandelight, Vinicius, a robotics expert on integrity robots, Tavi, a biologist in utilization of nature in engineering, and me, Alex, an expert on business application. We're Dandelight, and the future of space energy is here. Literally
3 minutes on the dot. Love the energy, and all I can ask is where can I buy it? But if the jury has also any questions, you can ask away. I think Sven possibly had one, but that's a safe pick always. And also Abedin.
Thanks for the pitch. Quick question. You mentioned that you could sell it everywhere. What's your first market and go-to-market strategy?
Our go-to-market strategy will be to check in with start prospecting around different agencies. For example, the Luxembourg Space Agency is already working on research and mining and are looking for robotics in there. And there are companies in commercial sector like Offworld and iSpace who are also looking for efficient solutions for robotics and power generation.
Yeah, but about what first market, would it be B2B or B2G, since you're mixing up those things?
B2B, I guess, would be rather.
Right, then you would skip the Luxembourg and straight to the companies.
We can see it as it goes on.
All right, thank you.
So, yeah.
Thank you, Sven. And a question from Abedin as well.
Hey, you did great presentation. Thank you. I just have a question about transportation of this kind of energy. How would that be done? I'm not sure about that.
Since it is really compact, when we actually did the calculations for getting it to Mars, as I said, it is 2 to 4 times cheaper than getting a nuclear energy power source. That is transportation included. Did that answer your question?
Thank you.
Thank you.
And we're on the sort of the finish line now. The last team about to come up, but what I would really like to emphasize as well is the fact that this team, Exio, you actually went to the hardware store and grabbed some stuff. So I think this is sort of the special prize that you're getting. But Kai, who's next up?
Seems that Vinicius wants to make a comment.
Yeah.
Yeah.
Yeah, just about the transportation logistics, just to add in some technical advantages, because this robot is based on a way that you can smash the robot, and it's the best technology to bring machines to space. Actually, as I can show you, like I can share the video quickly to you just to see how it works. If you can.
How long is the video, Vinicius?
It's 10 seconds actually.
All right, show us quickly then some extra. Go ahead.
The Easter egg.
It's shared?
Please do, yeah, but let's then try to do it quickly so we can move on to the next team as well.
Of course. You can see my screen?
No. Is it loading up?
1 minute. So as you can see here in my screen, are you seeing it right now?
Yes.
So in this video that Alex showed you, I'm just gonna show the last video. Like it's a functional prototype. We measure like how they generate energy through vibration, and the whole robotic structure is self-assembled. That means that basically you can smash the whole structure and drop it from the aerospace. As you see, you just smash it. You know, it's amazing solution to bring machines to space, because you can just smash and you can drop there and it can open. And yeah, that's it. Thank you so much.
Thank you. A little extra, like a little Easter egg, as Sim said. Nice. Thank you, Vinicius. We're going to move on. As said, one more team to listen to, and we had team Parapilet and Sergey presenting. Sergey, are you ready? Yes, you are. Again, another team that is coming, like, is stemming from personal experience and really has a good backstory to it. So, Sergey, please tell us.
Oh, okay. Hello. So my name is Sergey. I live in Czech Republic. I studied in Moscow, applied math and physics, and I'm a software engineer for about 15 years. And I'm passionate about space and robotics. And my dream is to work in the area of robotics in space research, because I believe that first inhabitants of other planets would be robots. Our team is called Parapilet, and we are building an autopilot for a paraglider. And by the way, I'm a paraglider pilot myself. So the problem is to reuse lightweight parts of rockets and to simplify rescue operations. So let's estimate the impact. Like one rocket fairing costs about $1.5 million, and each rocket has at least 2 of them. So it's $3 million expenses each rocket launch, which could be rescued. And also space capsule can be landed more precisely by GPS location, and it simplifies rescue operation. So the solution is to use a paraglider which can navigate itself by GPS and land softly. So with my team of Unity engineers, we built some simulation and the prototype, and I'm happy to share it with you right now. Yeah. Can you see my screen? Yeah, so first there is a simplified model and the Python simulation. So the first plot is the wind, which changes its direction, and it flows from the perpendicular direction to the movement of the model. And the second graph shows what uncontrolled paraglider does. So it drifts and it shifts itself like 3 meters for that time of simulation. And the last graph shows regulated flight. So it rejects wind disturbances, and you see that it oscillates around 0. So basically it can go straight ahead regarding the wind. So another thing which I'd like to show you is Unity model, which is the beginning of a simulator, which we're going to use to improve our simulation model. And also we have a video of the real line model, which is this one. Ooh. Yeah, so this is the physical device that we are going to continue building. And yeah, so the business model, we'll start with the lightweight payloads and the solve last mile delivery problem. So the payload will be dropped from the airplane and then it delivers itself to the doorsteps of the customer. And the main use case is reusing rocket equipment, which will save up to $3 million each rocket launch. The future plans is to work on real prototype, which can navigate itself by GPS and use computer vision to land precisely and get funding for further development. Thank you.
Super. Thank you so much, Sergey, for the presentation and really, really cool story there. All right, we're opening up the floor for jury questions. So if we have anyone, then please raise your virtual hand. Panayotis, you have a question.
Yes, I wanted to ask whether the conditions, are good for a paramotor to work. I'm not familiar with this condition, but I'm just asking whether really it's suitable for the conditions of landing on a planet or whatsoever.
Well, so far we are planning to use it on Earth. Yeah. But also it will be interesting application to use it, let's say, in Venus, not to land on Venus, it's too hot there, but to fly in higher layers of atmosphere and do some research. Or maybe it would be useful on Mars as well.
Also on Earth, which height are you going to be dropping it? So what's the height?
We're thinking about dropping it from the high altitude balloons from 40 kilometers, but open the parachute at the height about 20 kilometers.
Okay, good.
Thank you. All right, thank you. Any more questions from the jury? No, not right now. So thank you so much, Sergey, for presenting. It was really great. And really for all the teams. And now a big applause to you for presenting. Now you can just, breathe out the pressure is off now. Yes, I see you all clapping. That's really good. So we're done. 8 teams. Great job from everyone. And now we give the responsibility and the work duties over to the jury to actually go and make that tough decision. And we will be back in about 30 minutes. So stay with us, teams. I know you want to hear the results, but also you want to go and have a rest as well. So see you back in 30 minutes with the results from the jury.
Yeah, I think for coffee it's too late, but a glass of wine, I think you deserve it, or a glass of champagne.
Is there a... No, never mind.
Okay. See you in half an hour. Okay.
See you. Thank you. Bye.
And welcome back to the studio. I'm sure that you're all waiting there in Zoom to hear the results, and the jury has made the tough decision. And we already know, actually, the SpaceTech Europe online hackathon winners, and we're very excited to tell you as well. But before that, as Sim already said, we need to go back to the cliches. And before we announce the winners, we have to say, you are all winners, because at hackathons, everybody's a winner. And we say that every time, and I know it's cheesy, but it's true, because you took these 48 hours of free time. You could have done anything else. We have a big snowstorm outside, so we didn't go sledging. We wanted to really hack with you, help you to get to great results. And I'm super happy that you took this chance as well. Tomorrow's going to be terrible. You're going to be so tired and your workday might not be that productive, but really you took the time to create something, to really come and build something from scratch, do some great teamwork, get help from mentors, and now going to win some great prizes. So you are all winners and we praise you. We can't love you more. All right, but more thank yous. We've done this across the pitching, but we need to thank, of course, our mentors. And I'm sure that everybody, our participants in Zoom, are clapping right now because they got to speak to some great experts in the field and really get good feedback. Hopefully some critical questions were asked and answered as well. So thank you to everybody who took the time and mentored. I see some of them in the background here and clapping. Of course, we have to thank the team as well. This is the wrong button. Our team, and as hackathons go, we come here and we get to do this for 48 hours, but there's some people working in the background for months before, putting this together, talking to the community members, talking to partners, getting the prizes together. So thank you, team. Yes. We hear a little bit of claps in the background. All right, SpaceTech Europe online.
And thank you everyone for joining us. And we're offline.
Done. Let's go home.
No. I think there's something missing still.
There's something, a little bit of something missing. All right, so yeah, hopefully our participants are not signing off yet as well, because we have the results. And of course, we'd like to get our jury members to announce the winners and then talk a little bit about the process as well. It was a tough call. But for the very first prize, which is the favorite of the audience, I would like our jury member Mike to announce it and tell us a little bit about the team.
Sure, yeah, I think they may already know at this point. It's based on Facebook likes, but the audience favorite was Mineralis. Congratulations. I've been working for the State Department for almost 20 years, and this is one of the coolest things I've ever gotten to do. I was just so impressed with all the teams. But I want to give a special shout out to Mineralis. This idea of being an audience favorite. We live in this time where we talk about the wisdom of crowds or the importance of crowdsourcing, and to have the audience behind you is a huge thing, and I think it bodes well for all your work in the future. So just huge congratulations to you, and thank you for being part of this.
Thank you, Mike, and thank you, Team Mineralis. Really, really good job. Of course, all your fans and then showed it as well. But let's move on.
And the prize being, of course, that they'll get to go to the biggest. There's a prize, of course, as well. Like this is not just a little certificate, but you'll get tickets to the biggest business festival conference in the Baltics, Startup Day in Tartu, happening, I think, in August. Woohoo! Congratulations.
Congrats to the team.
So next up, before we get to the winners and the runners-up, we have 3 of the teams that will be joining the ESA-BIG Austria Sun program, and those will be announced by Aberdeen.
I always forget to unmute. I'm sorry, guys. I'm talking before then I unmute. Yeah, we have those fantastic 3 teams that you were in the running to get top 3, but you got this amazing opportunity to join Science Park and Graz. So those 3 teams are Mineralis, Orbitbits, and Paganel LPS. Congratulations, guys.
Congrats. But everyone joining us in Zoom, also please have your cameras open. We will love to see the reactions of you succeeding and actually winning. That's like at least 50% of why I actually do this job. So please show yourselves.
And there's actually, we can see you now. Yes, super. There was actually, you know, a lot of discussion happening in the jury room, and that's why, you know, these special mentions were given out as well, just, you know, to kind of show the teams that were left under the line that they did a great job. But we're going to move on now to the top 3, and the second runner-up is going to be announced by Panayotis. Please.
Hi to everybody. This was actually very tough. I think the most of the discussion it was for the second runner-up. We had a lot of candidates. The winning team actually it impressed me a lot about the passion of the presenter, and also a very impressive and disruptive idea of how this can change on the using different alternative energy in space. And our prize, which is the mentoring and the chance to apply for Gravity Incubator Program, goes to the team Exio.
Woo! Exio, where are you? Show us your
Alexander.
Happy smiles.
Here.
Any comments?
Yeah, it was an amazing journey, and like, yeah, it was certainly really cool to like compress all this knowledge that I had from my team into like this pitch to give to the people. It was certainly an amazing time.
Yeah, and since you and Tavi are in Estonia and Vinicius is in Portugal, if I'm not mistaken, so Vinicius, you have to come and visit us here, definitely.
I'm actually even in Sao Paulo right now. I'm traveling South America.
That explains the shirt as well. Very festive.
Yeah.
Nice.
But after the second runner-up, I think it makes sense to have the first runner-up. So the first runner-up will be given out by the team at Yuzhnoye and one of our mentors as well, Dimitro. Hey. I think you're muted. Okay. Hey.
Hello. Sorry. Hello, everyone, and we do really like to point. Sorry, guys. And our prize, our choice goes to Parapilet team. Great idea. We are really excited. About the idea, and looking forward to continue our communications, our discussions, and we will be happy to provide you with our expertise and the results of our analysis of your project. Thank you very much.
Second place, team Parapilet. Parapilet, and you win the project analysis by Yuzhnoye State Design Office, plus also mentoring from the Slovak Space Office. Sergey, are you here with us?
Well done, Sergey. Sergey is not here.
Congratulations, nonetheless.
All right, let's then move forward and announce the winner of the hackathon. We gotta get a drum here.
We'll fix it in post.
This will be announced by Sven from Esapic Estonia.
Yeah, hi everybody. The decision was ruthless. Heads were rolling. There was no one common vote for the winner. Everybody was opposing everybody. But finally, we figured out that the team is solving a future problem. And at some point and someday, with all the space race going on, with all space tourism blooming, their product will be necessary for our next step into the unknown or somewhere like that. So the winner is Team Flexiguns. Super nice pitch.
Argavan, are you here?
Yes, I don't know if my team is, I'm just speechless. I absolutely didn't expect it because some of the other projects are just really amazing, and I'm trained as a scientist, so I can see really the value in them. And our idea was really futuristic, and as one of the mentors said at the beginning, a little bit romantic. So we tried to really like worked on it, and I'm just saying like too many unrelated things because my adrenaline just jumped. But thank you so much. I like to, instead of talking, maybe my team can also say something if they want, but support that you gave us as the mentors, it was extremely valuable. And this is the first time I'm winning a hackathon. I'm usually a good second. And yeah, gosh, oh my God.
Well, super. Love to see those these emotions. Thank you so much for the whole team. And we said it before, you put it together from, great experts, and you found through the hackathon. So really, great job managing everybody and really putting together something amazing. So again, a big applause from the studio and congratulations.
I cannot still believe it. It's unbelievable. Thank you so much. And big thanks to the team and all the people who supported us and the mentors through the chat, through the videos in different times, and you guys for providing this opportunity.
Oh, that's great, team. This is it. This is why we do the job.
I'm a bit tearing up as well. Yeah.
This is so great, and I know you said it. There's so many people involved with this hackathon, and there's so many different organizers, and we're doing it online. And of course, it's not the same to give you a hug right now and congratulate you, but it's still great to see that we can connect then across different countries and different time zones and different continents, and actually, you create these amazing results. So congratulations.
Yeah, if I may thank my team again, especially Alexander, because the demo for the website, he spent an enormous number of hours on the website, and we had like last minute entries to the website for the pitch, and Alexander or Sasha, he also did a lot in the visual part. We had Alexander Tohidi from Australia, who was the person who designed the shell and everything, and like help us with the geometry. And it was really difficult for him to adjust himself to us. And then we had Laura, who pushed us beyond our limits because she talked about a space from the point of view of law, and we didn't know any of the topics that she was discussing. And then we had Natalia, which was the person who really helped with actually the business model. So I was not really involved in that, and one of the mentors, Oleg, he also helped us a lot in that respect. So thank you so much. Also Mahesh, Mikkel, and Lucas, who is not in this team right now, but he also supported us. And yeah, thank you so much. I don't know what the first time I'm reading something.
Thank you. This was a great speech, and great to see that you are, you're so happy and excited right now. So congratulations to the whole team, and congratulations to everybody who took part in the hackathon. Really, don't go away just yet. Just share your experience and maybe moments in the Slack channel, and it's really good to see you all here in the Zoom chat. Yeah, nothing. I don't know. I also got emotional. I would like to thank all of you for taking part.
Come on, guy, you're Estonian. Emotions,
I'll try
this shows how special it is that the Estonian are showing emotions. I'm not sure what's going on.
But it's always like that. Like these 48 hours. It's like I hope that everybody will have this, experience. And I was the one as well. I always tell that story. I think at every hackathon. How I went to a first hackathon and I tried to talk myself out of it, try to kind of find all sorts of excuses for not going because I was just scared. It just seemed a little bit weird and awkward, and maybe I don't have the skills. But then by the end of it, it's just always mind-blowing what you can produce. And really, like the 8 teams, you did just great, mind-blowing things here, and we saw the progress throughout those 48 hours with the mentors, and you really, really did a great job. So yes, Tai Ding is already clapping. I'm following his lead. See, what else? What's gonna happen now? We don't have, there's a hole in my soul now.
That's the hardest part, I don't know what happens on Monday. You get to go on with your lives, and we have this emptiness. That,
we stay here.
Yeah, we need to have the next hackathon. But what happens?
But there are next hackathons.
There are next
coming.
hackathons. Yeah,
oh
coming
my God!
up.
You can already join us next weekend.
Is it true? Yes, it's true.
It's true. Next weekend, if you want to join us for the next online hack already, then please do. The EU Africa hackathon is on. Maybe you want to take another 48 hours and develop your project. Your project forward, and I already see our veteran hackathon participants kind of going, "Yep, I'll sign up."
Yeah,
Davi,
but that's
you're gonna be there.
That's the the best prize of you won a hackathon. Here's a ticket to the next hackathon. So it's like a pyramid scheme.
Oh, I think we're gonna have a great celebration here in the studio. I would like everybody to come and join us here, so we can really show you all the mentors and everyone who is
Everyone
behind
that
the
actually
scenes.
made this happen. We are on stage talking like, what did we do? No one knows.
All right, we're gonna take a picture as well with all of you guys. So if you're there, put your cameras on, and we'll do a little bit of a.
Right now it's
how
just
does
us.
the selfie works?
Okay, let's do one. Let's do one that way, and then let's us go to the TV. And
yes, ready.
And then, okay, let's now flip and.
All right, but are we finishing the live stream?
Yes,
I don't know if
I think we
who's
can go
looking, but
offline
thank
for
you.
now.
Whoever was watching and took part of this craziness of the hackathon, thank you so much.
Don't leave in Zoom
yet. But don't leave Zoom yet, because we
We're
need a
taking a-
selfie. All right. I don't know how this is going to work.
Wait, actually, we can go. I'll go behind the TV.
That is true. All right, can you see yourself? That's the main
Tamara?
point. Oh, wait.
You need to also take the picture, yeah.
Okay, wait. Do you see yourself?
Doe zo lieve.
All right, we're done. Bye. Bye.